welcome to this week's episode of Automate It, Polymath Robotics weekly podcast. I am Stefan Oxmacher, and sitting across from me is a man with a Lego Creationist t-shirt on. Who exactly are you?
I'm the person who's back at that automated robot parking lot, manually moving cars around.
That's a story for another time. We just checked out some friends of ours, and they're really, really cool robots. This is, again, Automate It, our weekly podcast where we mostly do two things. We first spitball fun robots to probably never build, frankly. And then we talk about different issues in robotics. And Ilia, what's the issue in robotics we're talking about today? Or challenge in robotics?
It's basically how we choose sensors, how we want to deploy them for particular problems.
The answer to that's obvious. You use every sensor and then you narrow your way down from there.
That is a solution.
I mean, that's how you engineer things. You use everything. But before we get into that argument that I'm champing at the bit to get into, we'll play our game where every week we kind of simulate what it's like to start a robotics company, where we draw cards from a deck of technology and a setting for it. Usually, since I'm more tech limited, I draw the tech card. But this one, I have a real problem, Ilia, and that's that my house has been freezing cold for 2 months. In San Francisco, it has gotten as low, and I don't want this to shock you and terrify you, it's gotten as low as 51 degrees Fahrenheit outside. And that is too cold.
For the rest of the world, that's about 5 or 6 degrees Celsius.
Which is even scarier still. That's single digits Celsius outside. My heating bill as a result has been crazy. Literally $500 in PG&E and in electric and heat the last 2 months, for each of the last 2 months, just for my little 1,400 square foot apartment. And I want to find a way to save on heat.
First step, don't run the heating with your windows open.
Well, I want I want my awnings to be warm as well. I don't want to be selfish. So I was thinking maybe we do something that could solve that problem for me.
Yeah. You messaged me out of the blue over the weekend and said, geothermal.
Yeah. Why can't I just dig a 100 or 1,000 foot deep long hole in my backyard and let the hot air roll on up to me?
All right. So that's the topic for this week is geotherming drilling robots for your geothermal home heating needs. Maybe with a heat pump in there somewhere.
Yeah. Hopefully. I mean, if Bruce Willis can do this on an asteroid, why can't I do it in my backyard? And if Boy Scouts can build nuclear power plants in their backyard, why can't I build a geothermal thing?
Yeah. It's a good question. Why don't they just let you build a nuclear power plant in your
So
backyard?
as an
get rid of your heating problems.
As an interesting fun fact, the United States is one of the few countries in the world where if you own a piece of land, you de facto own all the stuff underneath it. So like whatever my lot is, 1,000th of an acre, I own that 1,000th of the acre all the way to the center of the earth, and I will exploit the heat therein.
That's right.
So why can't I just have a drill that just goes down incredibly?
Our mathematically minded producer just made a shape like, isn't it a cone?
Wait, what did I say? Triangle?
No, just
yeah. I own a cone to the center of the earth. So yeah. Why not just a little rover that you like throw in your backyard with an extension cable, and it spins and spits dirt up. And
this is starting to sound like
what?
This is starting to sound like the Boring Company.
Yeah, I want a personal boring company, not to make it so I can less conveniently get around Las Vegas, but more so that I can.
It's a callback to a previous episode.
More so that I can heat my house cheaper.
Yeah. All right. So what do we want to do here? We want the drill bit, obviously, right? So here's a question: why would I not just rent, an auger from Home Depot for the weekend and do my augering?
Well, I mean, with an auger, you'd have to keep on adding pipe and adding pipe and adding pipe. That was the main point of the Apocalypse Now, or that Bruce Willis movie, the Space Cowboys, Bruce Willis movie.
Oh, what was it?
That's the main part that I remember. They need a lot of pipe to get that auger down there.
Yeah.
I more want something that just kind of spins and as it goes down, it continues to push stuff up. So it probably has to simultaneously heat glaze the walls to structurally push the dirt up as it continuously slowly drills a hole into the center of the earth.
And you're still going to need the copper pipe to go down here.
Why?
Right? Because how are you going to use it for a heat pipe otherwise?
Well, why would you need? I just need hot air to come up.
Oh, that deep. You want to drill down like several kilometers. I thought you meant like drill down to reasonable human distances. Like in Canada for geothermal, for home heat exchanger, you only really need to drill down, let's say 30 feet to get to 4 degrees Celsius ground instead of minus 40 outside. But no, that's not good enough for you. Well, yeah. You want to drill all the way down several kilometers until it starts getting hot.
Well, what's useful about this too is then you could pour water down this tunnel, like create energy by doing that. And then when it gets to the bottom, turns into steam, it would create energy on its way back up.
So wait, let me unpack that sentence because this is getting truly ludicrous. You want to create energy by pouring water down a hole first.
Yep.
So this reminds me of the guy.
Eventually we add some turbines in there.
I was going to say.
It's a gravity battery, which is a real thing people are proposing building.
So I just
want one in my house.
This reminds me of the guy who wanted to run a Bitcoin mining thing in his apartment, was charged for electricity, but was not charged for water. So he built a water turbine in his bathtub and powered his Bitcoin mining rig that way.
Yeah.
This is the level of engineering we're doing here.
Or like the Bitcoin miners who bought old hydroelectric power plants.
Yeah, exactly.
To get some Bitcoin that's now worth one fifth what it was worth then.
All right, let's step back. Okay, so we were talking just before the podcast started about sending this kind of mission to Enceladus.
Yeah.
And what you could do there.
Enceladus, for those of you who don't know all of your minor bodies of the solar system, is a ice-covered moon of Jupiter, Saturn?
Yes.
Those gas giants all run the same. I don't know what it says about me, but when I see one gas giant, I mix them all up. But there's a big ocean underneath this ice sheet and Enceladus that's like under like a kilometer of ice or so. So like theoretically, you could put a little like ball on the surface of Enceladus that like has a nuclear reactor in it and just gets really, really hot and eventually would melt itself through that ice barrier. And you could see if like, hey, there's like intelligent seals down there or something.
You gotta love humans. We're like, we gotta explore and find out if there's life. Because if there is life, we gotta immediately radiation poison it. Immedially. Well, as quickly as we can.
How else will we know there was life if we can't destroy it?
If we can't immediately Chernobyl it.
Well, so another way to dig this hole in my backyard is a small nuclear reactor that just melts the ground all the way to the center of the earth.
So I forget, I think this is XKCD that did a calculation on this, on how much material you need to heat up for it to just sink under its own weight.
Yep.
And it was, I don't remember, but let's say several acres worth of nuclear material and lead that would be heavy and hot enough that it would just fall to the center of the planet. So if you want to take out most of San Francisco,
well, like, the thing I don't like about this is it's no longer a robot. It no longer needs to sense.
It's just a pile of hot metal.
Yeah.
It's just a pool of hot metal.
So let's go back to robots. So it needs to be able to dynamically navigate its way. Maybe there's some like sewer pipes down there, mole people, whatever. Yeah. We need to navigate our way around them as we drill continuously towards the center of the earth.
I feel the mole people and sewer pipes problem is the like first 10 meters problem, and the next several kilometers.
I've heard
just
the mole people are
shot.
pretty deep down there, yeah. And then at a certain point you get to the hollow earth, and it's a whole other set of people,
and then it just falls.
Yeah, then
you're fine.
You're good.
So we have not discussed this robot at all. We don't really need a guided system. We need it to stay straight-ish.
Yep.
We need a drill bit on there. Yep. I don't think we actually need any sensors. Maybe an IMU for figuring out which way is gravity to aim a little bit, but not very much. I mean, these pipes are very thin too. These pipes tend to be only several inches across.
We could run water down into it to make it easier to, like, basically we could remove the dirt by just sucking muck up with a hose.
Just flooding it.
Yeah. So we just, California's got plenty of water. It rained for like 2 days. So as it's drilling its hole, we have a hose putting water into it and another hose that's like pumping the mud out.
You know what makes your robots easier? Needing to completely waterproof them. That always makes for an easier robot job. I think what you're describing now is the average drill head of an oil drilling rig, at which point this is not even a robot, it's just a drilling rig.
Well,
just a drill head.
Well, the thing is, if it hits rocks that are too hard, you'll get into trouble. So you need to sense those and then plan around them.
I think you just drill right through them.
I don't think I need to plug this into my wall. I'm not gonna have enough electricity.
I'm not saying you're gonna do it quickly. You just diamond grind away at any granite you hit with just a slow diamond burr. It doesn't have to be big.
All right, so what's our bill of materials look like for this?
I don't know. How much does the oil drilling rig cost?
Well,
and what is the permitting process to ask San Francisco to set up an oil derrick?
I think like the 10% of apartments in San Francisco that are illegal, this is a don't ask, don't tell type of situation. I think you just start drilling, baby drill, and then you're good.
Yeah, eventually hit those mole people and establish new diplomatic relationships.
So we need a garden hose to put water in, a much longer garden hose to get mud out, and a pump.
Yeah.
For actually drilling. Motor is going to be decently expensive. The drill body is going to be decently expensive. And then, like, I don't know, what do you think is the best way to perceive where the rocks are? Is that like ground penetrating radar if you're underground?
I tell you, just diamond drill bit right through everything. Just go straight. But if you really had to do it, probably underground radar is your best bet.
Yeah.
But you have to stop, measure.
Yeah, I mean, I think of this as more of you put it in your backyard and like months later you have a hole. That's important. That does the job for you. It's like making progress measured by like inches a month. So I think like probably our bill of materials, since we haven't established what motor we need, probably going to range anywhere from $5,000 to $50 million.
It's a fine range.
Right in that hobbyist budget.
Yeah.
But however, if you drill this hole, you won't need to pay for heating or electricity anymore.
Yeah, because you'll be in prison.
So what should we name this? What should we name this bad boy?
I don't know, but I'm sure you'll add a 3,000 to the end of it.
Mole Beater 3000.
Mole Beater 3000. All right. Coming to you or to Enceladus to radiation poison the entire backyard soon. And we're back. So let's talk about picking sensors.
Yeah. So when people think about, let's say, self-driving cars are the main place that people really love to talk about sensors, they start coming in with a bunch of strong opinions about sensors.
Speaking from experience. Right?
Yeah. So at my last company, Starsky Robotics, we were a famously anti-LiDAR shop in a time when everyone was very, very, very pro-LiDAR. And people liked to think that was because we were like contrarian or whatever, but we only cared about driving in complex environments when we were going so slow that teleop could solve the problem for us. And at highway speeds, there frankly wasn't a LiDAR that could do anything for us. At 60 miles an hour, a fully loaded truck has a stopping distance of, I haven't done the math in a while, but I think about 300, 400 meters, which is 3 to 4x the sight range of any LiDAR. So at the time, if we had the best LiDARs in the world and they hadn't fallen apart because they were hot glued together at the time, which certainly never happened, we would have had to see an obstacle and immediately fully decelerate, and then we would have still run that obstacle over by about 300 meters. So it wasn't like very useful. What I've seen working on Polymath is people have really strong opinions about sensors. Like at Starsky, every investor call would start with a good 5 to 10 minute defense of why we don't use LiDAR. At Polymath, we talk to customers who like absolutely need to use this specialized thermal IR camera, or absolutely will never use LiDAR from this particular manufacturer, or absolutely does not think that there's a reason to spend the money on LiDARs at all, and why can't we do it all with just ultrasonics or something? I don't know. Like, how do you think about like what sensors someone should use or not use?
Yeah. It's stepping back. I think one of the things we should talk about is there's this kind of engineering fallacy to say, I'm going to throw everything in the kitchen sink at it, and then I'll pick what I need and step back.
But like, why is that a fallacy? Like, why not start with everything to prove that it's buildable and then like narrow out what's not important?
Well, from our previous MVP episode, we really got to figure out what we actually care about, what we're trying to prove out. And most startups and even bigger companies, we were
just trying to prove out it drives.
Yeah, exactly. But to it drives doesn't need every sensor on the planet. Most startups and even most companies won't have the budget to just buy everything. And the problem I've seen happen, especially at larger companies where you might have the budget approaching to buy everything, is really tempting to buy the most expensive sensors, put as many of them as possible on there, and then kind of say, we'll optimize down from here in production. But the really what happens is, as an engineer, if you're, a year, 2 years, 4 years, whatever, into this project, every time you try to remove a sensor, you look at your metrics and your data you've gathered, and the answer will be that it will perform worse. It will always perform worse with less sensors unless you have no idea what you're doing software-wise, which most of these companies know at least something. So it's really hard then to make an argument that it's a good idea to remove a sensor, because somebody will always have a good, valid counter-argument that it will make your performance worse.
I think even besides the making your performance worse, when you start using stuff, you start needing stuff.
Yeah, exactly.
And it's with these types of systems, they're so complicated that if you've kind of integrated with something, you're kind of stuck forever.
Yeah.
Like there's not it's not we chop this LiDAR off and we're just as good. We just cost a little bit less. It's none of our models look in that direction without that LiDAR installed. So let's retrain everything.
Yeah. A great comparison Nicole came up with was it's kind of like your living expenses.
Mm-hmm.
So, if you get used to living at a certain quality of life, it's really hard to cut down.
Like
from there.
Eating on a regular basis, taking private jets, maybe getting your hair cut by a professional.
Yeah, those are all the same thing. they're all equivalent problems. So same with sensors. And I think especially for startups out there, what you really got to do is you really got to think of what is the particular special case of your application. So think about things like, what is the environment? Is it dark? Is it light? Is there dust?
So I actually want to call out something that you said and disagree with you. I don't think this is a problem just for startups.
Yeah,
I think there's a fallacy that like startups can only afford to do blah, blah, blah. And big companies can do it afford. Like, I actually don't think the big companies can afford to use everything either.
Yeah.
They can't afford in terms of bandwidth and focus, and they can't afford in terms of money. I think like a big part of why startups frequently outcompete large companies is because the lack of money means they have to focus on something so incredibly narrow that it has to be both buildable and valuable. Whereas big companies can kind of dither around and build fun stuff with no real purpose. The dithering around makes for worse engineering.
Yeah.
Like frankly, if engineering is the navigation of constraints, not having constraints leads to worse engineering. Yeah. It's not like we can afford to do it, so we're going to see how it goes. I mean, that's kind of like, to talk about the lifestyle creep again, I can afford to blow up that helicopter to see if it looks cool, doesn't necessarily lead to a good outcome in an individual.
Yeah. And this especially is prevalent right now in and for the last few years in the self-driving car, self-driving truck industry, mm-hmm. where a lot of companies have taken the approach of putting every single sensor they can get their hands on. And there's a valid case, right? You can always make a good argument that a LiDAR here will improve your safety margins and will improve your perception. That is always true.
I mean, listen, I don't know why no one's solved the problem that if you don't have a LiDAR on the undercarriage of your vehicle and you're driving on city streets and somebody sticks their head out of a manhole while you're over them, you won't decapitate them. And that's an unacceptable safety risk because maybe that's happened before.
Exactly.
Or Cape Fear. You won't detect the Cape Fears going on.
That is always, Cape Fear is always a possibility. But yeah, so my argument would be design the other direction. Start with what is absolutely the most important thing for you to operate in? Is it daylight or nighttime? Is it snowstorms? Can you start operating in fair weather conditions? So during the day with clear weather, with little traffic, for the self-driving car example, what is the minimum set you have to do to just lane keep? Or just lane keep and make turns or build up.
Or just drive from this side of a port to another.
Exactly. That sort of thing, usually you can get away with a very small set of sensors. In picking those sensors, what you want to do is you want your sensors to have what we call kind of orthogonal modalities. Mm-hmm. So to unpack that a little bit, it's sensors that sense in different ways from each other. So an ultrasound uses sound waves, a camera uses light. So if something's very poor, like you're traveling at speed, there's a lot of wind noise, your ultrasound doesn't work very well, but your camera will.
We tried that at Starsky. We put ultrasounds on our trucks to try to help us get through toll plazas, and mostly driving at 20 miles an hour made the sensor useless.
Yeah, exactly. But vice versa, if you're coming up really close to something at slow speeds, your cameras don't have a good understanding where it is, but your ultrasound might.
Yep.
So you try to build out these modalities. So let's do a concrete example. We're going to be doing farming. We're going to be doing farming where we want to do tilling when it's early spring or so on. It's a dry field. So as we're driving, we're kicking up a lot of dust. So we know that our optical sensors will get somewhat stymied. We might want to add ultrasound at those speeds. Minimum set, just ultrasound, GPS, and IMU. You'll get a basic navigation system. Then you add on the question, okay, but now I got to worry about people. Can we use thermal cameras? Can we use LiDAR? Build up from your requirements. Don't just say,
let's start with everything and work down.
Yeah, I need a tractor that can work in any condition, under any field, with any person, with a person in camouflage who's lying on the ground.
In Kansas, in Turin, or on the moon.
Exactly.
Like that's MVP.
Yeah.
It needs to work in those three places.
Yeah. And again, to your comment, the big company lack of focus thing will happen when there's a lot of stakeholders, and stakeholder A will think that Kansas is the most important market.
Yep.
And stakeholder B will think the moon is the most important market, and you'll get kind of the worst of both worlds.
Another part that I think about this is related to a blog post I wrote on Forbes a couple of years ago. When you throw everything in the kitchen sink at a problem, it ends up being really, really complex.
Yeah.
And when that system is so complex and it needs to be safe, it becomes really hard for it to be safe.
Yeah.
Because you don't really know how everything interacts. So like at my last company, we came up with this idea of Occam's safety razor, where Occam's razor is the philosophical idea or logical idea where that which is simplest tends to be true. I could either be talking to you right now in 2023, or it could be a projected out hologram from 500 years in the future. It's a little bit simpler that this is in real time. And Occam's safety razor being that simpler systems, because they are more understandable, tend to be safer than those which are so incredibly complex that you need 3 weeks to even understand how the system kind of sort of works.
Yeah. And even in building safety systems and in building complex systems, you should absolutely sit down and do an FMEA failure mode analysis to go through and figure out what is the risks you have and how you plan to mitigate them. Not arguing against that. You should absolutely do that. But the risk is you take that too far and you spend weeks on that and you come up with a ton of crazy scenarios, because not only will you overspecify and get the problem of throw the kitchen sink at it, but most of the time in testing, a lot of things you hadn't thought of will be the actual things that cause problems.
Absolutely.
For you. So you got to close the loop and come back and keep iterating and do that. Start simple to be able to quickly iterate.
Problems like your system, for example, running out of charge because it's a rolling data center. And suddenly it's not so much that you don't have blind spots, but it's that parts of your system are shorting out.
Exactly. Yeah. And the last part you got to consider is not only the environment itself and your use case, right? So how close are you operating to humans? What do you expect to see in your environment? Is your environment enclosed away from people or in the public road? The other thing you got to consider is how big is your vehicle and what kind of work is it doing?
Yeah. I mean, if your vehicle doesn't need to be close to people, you can have a very, very unconfident system that triggers the first time it sees a person, whether that's 100 meters away or 50, because, hey, we shouldn't be seeing anything pop up 5 meters away from us. If, for example, we're a 400-ton vehicle traveling 25 miles an hour. On the other hand, if for example, you're incredibly bomb constrained and you can't afford that much hardware, then maybe you can't afford to drive all that fast because you won't have enough sensing to be able to see stuff far enough away for you to make a safe reaction to it.
Exactly. So all this to summarize is it's very tempting to use everything. Yep. And the other flip side of this temptation is the temptation to think that there's a silver bullet sensor.
Yeah.
Like this one sensor will solve all our problems. Right now, that tends to be cameras. A lot of people are saying cameras plus machine learning, all our problems.
Well, I really like that idea. I mean, at Starsky, we were more of a camera shop and thinking, hey, if humans can see it, we should eventually, we should be able to see it too.
That's a great theory. Eventually, the comparison I kind of give is the human brain. Even our best computers are kind of approaching, mouse level of consciousness and intelligence. It's a rough rough metric. There's all sorts of
some of those
nonsense.
mice are very talkative.
Yeah. Nonsense metrics, computers don't really compare to neurons. But, are you comfortable giving a mouse a 60,000 ton truck with no extra safety systems built in just based on optical input? Or do you want to have another safety system built in?
Yeah.
You might want to. Yeah, but still, I think vision is probably the right way to go. I think a lot of our built universe is built around human vision, so it's not a bad assumption. I think we're not there yet, and I think making a bet on that today will be a poor bet.
Unless you have a very relatively large machine learning budget and a very narrowly definable environment.
Yeah.
So like if you're talking about like specific highways in specific states, maybe.
You're right.
If you're talking about, anything you might ever see in a port or in a forest or in a wherever, that's probably not too realistic.
Yeah. I mean, we've talked about Tesla a few times, but they arguably have one of the largest machine learning training systems on the planet, both in terms of raw data, in terms of computing power, in terms of you name it, right? And I think even they would admit that they're not fully ready for full autonomy, even on just road use cases.
I don't know if they'd admit, but they wouldn't ship.
Yeah. It's kind of the same thing. And especially even they, with just using camera data, still have these accidents where there's false positives or false negatives because the training data set didn't capture a white truck flipped over on its side, reflecting the sky at the top of a hill, hence confusing the camera systems, thinking it's a clear road.
So let's do a quick lightning round.
Sure.
That I just took Ilia's set of cards on different settings, and I'm going to ask him random robots that I can come up with for what type of sensors. So here's a good one. What about a good generic home robot?
Home robot. Well, this is a bit loaded because I just worked on a project like that. We use structure. So the Astro program used structured light and cameras, IMU. And
what is structured light?
So structured light means that the sensor projects out a timed pulse of light.
Yep.
And then waits for how long that light bounces off of objects and comes back to the sensor.
Yep.
So think of it as a camera, but for depth.
Yep.
So it's a depth camera, right? So that plus camera data plus encoders on the wheels and an IMU was basically the whole set.
What about a delivery robot in a dense city where your bill of materials, like a sidewalk delivery robot, where your bill of materials probably can't be over $3,000 to $5,000?
Yeah. So the trick with structured light sensors, coming back to those, is they tend to underperform in direct sunlight. There's been a lot of companies who are working on that right now, but the sun is just such a bright emitter that structured light tends to underperform. So instead of structured light in that case, I'd use LiDAR, much further range, but more limited field of view, less data dense. So replace structured light with LiDAR and add a GPS, but otherwise unchanged.
What about a yard truck in a port?
Yeah. Main visibility problem here will be the actual trailer behind you. So you want to have a few more LiDARs instead of just one. You might have 2 or 3.
Yep.
Not like 12.
Yeah, you're probably replacing a person who makes $35,000 per 8-hour a day shift. Or sorry, makes $35,000 per year, and they work like an 8-hour a day shift, 40 hours a week.
Yeah. So you could get away with, let's say, $2,000 to $3,000, $4,000 to $6,000 LiDARs, 2 to 3 cameras, GPS, IMU, and that'll be good enough.
And to find a fun or relevant last one.
So note, right, on the use case there on that last one, we're assuming this is fair weather systems, right?
Yep.
If it's a super foggy, storming day and you expect it to continue operating, you need to add more sensors.
How about vehicles in a low connectivity like farm?
Yeah.
Without many, like a feature poor low connectivity farm.
Yeah. I mean, if you look at the farming community, we mentioned this briefly, I think last time, but they've really picked up on GPS only auto steer.
Mm-hmm.
So it's really GPS plus an encoder on the steering column is all you need to get your vehicle to drive.
Mm-hmm.
So if you needed to make sure that it just doesn't hit a thing, you could get away with a very simple planar LiDAR set at roughly, knee height.
Yep.
Or whatever your crop is, crop plus some tolerance height, and you would avoid most of your collisions. It wouldn't be a perfectly safe system, so you'd still have to expect people not to wander out and pass out in front of this thing, but humans wouldn't notice that case either.
Yep.
So you can get away with shockingly few sensors just because GPS is so good at those farm sites.
Well, I think that's it for this week. I'm not going to hammer you with too many more lightning rounds. Now to ask the question I ask every time, but maybe this time we have an actual answer for. What are we talking about next week?
Yeah, this time I'm excited to talk about next week. We're going to talk about how demos go wrong and what are all the breaks.
Hardware demos never go wrong. If there's one thing I know, if it's physically built, it works.
Yeah, absolutely. I mean, when the robot crashes through the wall, Kool-Aid Man style,
it was supposed to.
Working as expected.
Yeah, that's what the binary tells us to do.
I think we should get t-shirts printed with workings as expected for our listeners.
Well, that being said, thanks so much for joining us this week on Automate It. And let's hang out next week too if you want to.
See you next time.